So for this question, part A is pretty straightforward. Part B is where it starts to get a bit more complex. We have to know exactly what the particle is doing in those first 2 seconds to be able to work out the total distance travelled. So for part A, we're told that the particle is projected vertically upwards from level ground with a speed of 14 meters per second, and then we're trying to determine the speed and the distance of the particle from the ground 0.5 seconds after projection. So let's draw a SUVAT table. We know the initial velocity is 14 upwards, so let's say that upwards is positive, and let's stick with that for the rest of the question. So the acceleration will be downwards, and therefore will be negative. The time is 0.5, and then we're trying to work out the distance and the final speed. So if we work out velocity, if we work out displacement, that will tell us what we need to know. So just a quick clarification between distance and displacement. So when you're working out displacement in this equation, that tells you the vector between the start point and the finish point. So if you have a projectile that, let's say, goes up and then comes back down to here, the displacement, so what S tells you in this SUVAT table when you work it out, the displacement would be this vector that goes from there to here. It wouldn't tell you the full distance traveled all the way up and then all the way back down. Now in this question we're trying to work out the distance of the particle from the ground, so the displacement is fine. Whatever this vector would be, that would be the same thing as the distance of the particle from the ground. Okay, so SUVAT we can use to work out S. S equals ut plus half at squared. So S is then going to be 14 times 0.5 plus a half times minus 9.8.5 squared, and that's 5.775 meters. So that's our first answer. We want to work out speed as well, so we have v, u, a, and t. We can use v is equal to u plus at. This is then 14 plus minus 9.8 times 0.5, and that's 9.1 meters per second. That's part A done. So part A is pretty straightforward. Part B, calculate the total distance travelled by the particle during the first 2 seconds of its motion. Okay, so this is where we need to consider what I was talking about before. We need to know, is the particle going up and then coming back down? In which case we need to consider 2 different stages for this question. Or is it just simply going up, in which case the displacement will just simply be the same thing as the total distance travelled? The fact that it's 7 marks, more than what we had before, suggests to me that what's happening here is the particle is going up and then back down, and we're going to have to break it up into multiple stages. We can verify whether the particle is going to be going up and then coming back down by working out the time it takes to get to max height, and then seeing if that is less than or more than 2 seconds. So, SUVAT table in this case is going to be similar, but not quite the same. Acceleration is unchanged. Again, upwards is positive. Initial speed is unchanged as well. So now, if we're working out the time it takes to get to max height, at maximum height, the ball stops for a moment, so the final velocity would be 0. The ball stops before it starts to come back down again. And then we can work out time from these 3 quantities, so we can use v is equal to u plus at, t is then v minus u over a, which is 0 minus 14 all over minus 9.8. And that gives us 1.43 seconds. Okay, so that means that if I were to represent this on a diagram, let's say here is the ball to begin with. It goes up, it comes back down, let's say it gets to here. Now the time it takes to get from here all the way to the top is 1.4 seconds, or 1.43 seconds. And then it spends the rest of the time falling, so it takes a total of 2 seconds to get to this point. 2 minus 1.43 is 0.57 seconds. Right, so we want to work out the total distance up and the total distance down. one way to do this is to work out the displacement in the first 1.43 seconds. So we'll start with that. So we'll work out the distance that the ball travels when it goes all the way to the top. So I'm going to use v squared is equal to u squared plus 2as. This means I won't be using my time answer. So if I had made a mistake, if I were doing this in the exam, if I had made a mistake with t, then I wouldn't be using that answer again to then work out what s is. S is then, so rearranging this, it would be v squared minus u squared all over 2a, which is then 0 squared minus 14 squared all over 2 times minus 9.8. And that is exactly 10. Okay, so that's 10 meters. So therefore this distance here is 10 meters. I'll just put that here as well. Okay, so the distance from the bottom to the top is 10 meters. So what is now this distance here? Well, what we could do is we could, with a new SUVAT table, there's different ways in which we can do this. We can either consider the journey from there down to there. That's one way of doing it. What I'm going to do is consider the same starting quantities. So initial speed, still 14. And I'm going to say that the time is 2 seconds. So that time basically is the time for the full journey. If I work out the displacement, that gives me this displacement here, the vector that points from start to finish. And then I can just do 10 minus that to get this distance up here. Okay, so we can use S is ut plus half at squared. S is then 14 times 2 plus a half minus 9.8, 2 squared, and that gives me 8.4 meters. So orange distance is 8.4 meters. The distance therefore just above that would be just 10 minus that, and you'd get 1.6 meters. So our total distance would then be the 10 meters that it travels on the way up, plus the 1.6 meters that it travels on the way down. That represents the first 2 seconds of travel. That'll be 11.6, which is our final answer.